Today, we're going to be converting repeated decimals into fractions. This is a very difficult topic, so please pay attention. So let's say I have 0.14 repeating. That bar notation indicates that the 1 and 4 are going to be repeating. So forever and ever, we'll say 0.14141414, and so on and so forth. We are going to turn that into a fraction and actually try to quantify it. So what I'm going to do is step 1, make this value equal to x. So I will say that x is equal to 0.14 repeating. Okay, I know, big step so far, but it'll be easy. But now I want to take everything that I have after this decimal and turn it into a whole number. And I need to multiply both sides by a power of 10 to make it a whole number. So since this goes to the hundredths place, 1, 2, I'm going to multiply by 100 on both sides because it goes 2 places down. So that's 2 powers. So this will be 100 times x equals 14.14 repeating. Remember, this 1,4 is still there because it started here. If I multiply this by 100, the 1,4 is still going to repeat even after the decimal. I'm just not showing you the 1,4 forever. And now, I really don't want this 0.14 here. I don't want it. So what I'm going to do is subtract it. And how am I going to do that? I'm going to use this first x to help me find it. So since I know that x is equal to 0.14 repeating, and this is just another way of saying 14 plus 0.14 repeating, this x is just right here. So this is just like saying 14 plus x. So now I'm going to subtract this x from both sides. So I'm going to take away the 0.14 here, and I'm going to from here. And that, since that is equal to x, I'm going to take away one of the x's. 99x equals 14. I am taking that away. I'm subtracting that x. So that means that 0.14 repeating is getting taken away. I'm taking that x away. And now I'm going to solve for x. So to get x by itself, I have to divide both sides by 99. That cancels out. So x is equal to 14 over 99. Let's look at a second problem. Let's say we have 0.6 repeating. So I'm going to, step 1, make this value equal my x. X equals 0.6 repeating. Now I want to make this a whole number. So I'm going to multiply by how many? By just 110, because it's in the tenths place. It moves 1 space. So I'm multiplying by 110. So this becomes 10x equals 6.6 repeating. And now, since I want to take away that 0.6 repeating, I want to get rid of that repeating decimal here. I am going to see how many of these x's, how many 0.6 repeatings does it take to get there. If we remember that 6.6 repeating is just 6 plus 0.6 repeating. So how many x's do I need to take away to get rid of this 0.6 repeating? Just 1. So I am taking away 1x from here, because now I'm going to cancel out that. So now it's 9x equals 6, divide by 9, and x equals 6 over 9, or x equals 2/3. So that's how we can turn a repeating decimal into a fraction. That's how I can solve for it. But for this one, it's a little different. In our first problem, we had both in 0.14 repeating, both the 1 and the 4 were under that bar, but now it's just the 7. The 2 is not going to be repeating, just the 7 is. I'm still going to follow the same steps. I'm going to make this value equal to x. X equals 0.27 with the 7 repeating over and over. Now I'm going to multiply by a power of 10 to make this a whole number. So since there are 2 values after the decimal, 1, 2, that is how many powers of 10? 2. 10 to the power of 2. So that will be 100x again equals, since I'm moving it here, it's going to be 27.7 repeating. Remember, the 7 is still going after because the 7 is still repeating forever and ever. I just wanted to get everything out here in front first. And now I'm in a little bit of a struggle because I have this value, 0.27 repeating, but this is just going to be a little bit more different. So I need to figure out a way where I can multiply this to get somewhere where I can just where I just only have the 7 after the decimal repeating. Right now I have the 2 in the way. So remember, we have to go back to step 2 now. Multiply by a power of 10 to get a whole number with maybe with a decimal repeating after it. So how could I get this decimal? How could I find a way to get just the 7 repeating after a decimal? Well, before we moved it 2 places to get both of these. But now I'm only going to go 1 place here because now that it would be just 2.7 repeating. Sorry. And since I moved it only 1 place, that is 1 power of 10. So that is 10x equals 2.7 repeating. So before we were able to just do, okay, minus x, because it worked out. But since I had to change the power of 10 to get just the 7 repeating now, I only have 1 power of 10 to work with. So I'm not going to subtract just 1x. Since both of these have just the 7 after repeating, I'm going to subtract these 2. I'm going to subtract all of this. So I'm going to do 100x minus 10x, get 90x. And then since the repeating 7s cancel, I am just going to do 27 minus 2 equals 25. Now I'm going to solve for x, divide by 90. They cancel out. So x is equal to 25 over 90. And we can check this on a calculator. But now you're asking, Mr. H, what if there's a whole number? We've done stuff with just values between 0 and 1. But we got a whole number now. Same steps. I want to make my value equal to x. So I'm going to say x equals 3.8 repeating. I'm going to multiply by a power of 10 to make a whole number. So how many places do I need to move? I only need to move 1 place. So I'm going to multiply by 1 power of 10. And 10 to the first power is just 10. 10x equals 38.8 repeating. Remember, the 8 is not going away. And now I need to see how I can get a value where I can subtract the 0.8 repeating. What's nice is that the x and 10x both have a 0.8 repeating, have the 8 repeating after the decimal. So I can just subtract and get my answer. 10x minus 1x equals 9x. The 0.8 repeating cancels out, and this becomes 35. X is equal to 35 over 9. Do you have to turn this into a mixed number? No. Do you have to simplify? No. You are still going to get the answer like this. The last one is going to be a tough one. We have a whole number and we have a situation where not all of the digits are going to be repeating. We are still going to follow the steps, make this our X value, 4.235 repeating, and the 35 is the value, or the values that are repeating. So now I need to see how I can make this into a whole number and still maintain the repeating decimal after. So I need to move it 1, 2, 3 places. So that means I'm going to multiply by a power of 10 to the third. 10 to the third is 1,000. So now this is times 1,000. So it's 1,000x equals 4,235.35 repeating. The part that is still in the bar notation is still going to be after your decimal. And now I have to figure out a way where I can only just get the 35 at the end. So I'm going to clean this up a little bit so that we can see this a little more clearly. So right now I have a decimal here, my decimals here. I want to be able to get rid of this 0.35 repeating. The X that I have currently has 0.235 and the 35 is repeating. That is not going to work because this and this don't match up. But what I can do is multiply by a power of 10, the X by a power of 10, to shift this decimal down one more spot so that I can get this decimal here. How many places did we move it? 1 place. So since I move it 1 place, I am multiplying by 1 power of 10. So that means 10x would be 42.35 repeating. And now, since I have the 0.35 repeating in both of these equalities, I can cancel them out through subtraction. So now I'm going to subtract everything. 1,000x minus 10x is 990x. And then I cancel out these guys because remember the repeating decimals can cancel out when we subtract them. So now I just have 4,235 minus 42. 5 minus 2 is 3. 3 minus 4, I have to regroup. 13 minus 4 is 9. 1 and 4. So now I have 990x equals 4,193. Then I solve for x by dividing by the coefficient in front. So 4,193 over 990 is x. And this is your repeating decimal.